So can we move on to the next slide? So the agenda of today is we will start with the workshop objectives and the outline of the workshop. Then we'll have an introduction to LCA. Then we'll have a very short break of 5 minutes. And then we will go to the practical examples, which we had prepared for you, which um, it's on olive oil. And then we will go to next steps and final remarks. So just to end my introduction, I would like to present the team. So I will start by introducing myself. I am Dr. Mariale Moreno. I am an industrial designer, but I have a PhD on circular economy and sustainability. I have a lot of experience in regarding design and manufacturing, and I have worked in different research projects funded by the European Commission, but also before living in Portugal, I was in the UK, so I work also in quite a lot of research projects funded by UKRI. Then we have my colleague Eduardo Santos, who is the managing partner at Three Drivers. He is an environmental engineer with more than 16 years of experience in projects related to life cycle assessment and waste management. And also we have our colleague Ana Braga, who is a material engineering with more than 8 years of experience in projects related to processes and materials. And she's a technical consultant at Three Drivers. So that's all for me now. So thank you so much. Sorry, no, I'm missing the workshop goals. Sorry. So regarding the goals of the workshop, we have the following objectives, which is to understand what LCA is and how it is conducted. We will also understand what type of data is needed to conduct an LCA, and also get to know the existing tools to conduct an LCA, mainly the softwares that are available, and also to gather some insights of the use cases for LCA within the project. Um, some of the learning outcomes for these sessions are to define the objective and scope of an LCA, define and understand what is a functional unit, also to develop data inventories for materials and processes, quantify the environmental impacts, interpret those results, and also why it's important to take a whole life cycle approach to calculate environmental impact. And then also is how the LCA will be applied in the different use cases. So what are the greatest stages? What are the stages with the greatest impact and possible mitigation strategies? So Eduardo, you want to go next? So and now that's it all for me in this introductory part of the workshop. So now I will let my colleague Eduardo to introduce the theoretical part, which is getting acquainted with LCA.
Okay, so hi everyone again. Um, so this is the first part, which is the theoretical basis for the LCA methodology. So this is a bit of a more like heavy part of the of the workshop. So I ask you as much as possible if you can be aware of the topics, but of course we will also have a second part of the workshop where we can have a more practical example to see in practical what the LCA is used for and how it's used for. But for the moment, we will start with the fundamentals. And so just for a quick or a brief initial note, we have put a few more slides than those that we will be presenting today, because we will also be sharing this presentation with everyone. And so you can use them later on to maybe read them. But so I will skip a few of the slides for topics that are not so interesting or that we have not so much time today. So I will do this. But anyway, they will be included in the package that we will send later. So beginning with LCA. So it's LCA is life cycle assessment. It's a tool that is used within the industrial ecology toolbox, let's say it. So industrial ecology is basically a science where you address the industrial processes in a way that is similar to natural ecosystems. So there is a big parallel that you can address. And LCA is one of the fundamental tools within this toolbox. So it's used basically for environmental impact assessments, so mostly for the environmental aspects, not so much for economic aspects, but it can be used as well together with other methodologies to develop analysis for economy and economy together with environment. So it's a pretty fundamental tool for the industrial ecology science that can be used for many other tools. So I would say that together with other applications, it can be also used to do the assessments, not only for environmental aspects, but also for economic aspects together with those environmental ones. I would say that there is two main perspectives. So there is the perspective of cradle to grave, where you basically analyze the product system from the beginning of the life cycle until the end. And there is also a cradle to grave perspective when you are looking only at the perspective of the production of the product, and that is enough, and you don't need to assess anymore of those aspects. So those two perspectives can be chosen based on what your goal and the scope of the life cycle assessment is. So it's important to have a first idea of the definition of what life cycle is. So life cycle is a consecutive and interlinked stages of a product system. So they begin with the raw material extraction or generation from natural resources until the final disposal. So it's this complete set of stages from the product system. Also, from this life cycle definition, we can then draw the assessment, so life cycle assessment according with ISO 14040, and it's a compilation and evaluation of the inputs, outputs, and the potential environmental impacts of a product system throughout its complete life cycle. So there is a set of standards that currently exist for from ISO. I will not take long to talk about this. It's something that you can search and then check what the standards address. But it's the most important thing is that this is a methodology that is not only standardized from the point of view of the science, so the scientific methodology, but also from the standpoint of certification or formalization of processes within the ISO standards. Um, Despite this formalization, LCA cannot be certified, so a given LCA cannot get a certification from ISO. This has to do also with the fact that LCA is a relative methodology. It's in its nature, so it's not something that is its relatives depends on references, and those references may vary, especially according with the goal and scope of the life cycle assessment that you want to develop. To do the LCA, so it's basically a structure processed based LCA model. So the operationalization of an LCA is basically to set up a sequence of processes, and those processes may include other sub-processes, and then continuously until you get to the baseline process, which is the fundamental for the LCA accounting. Also, from the perspective of the LCA nomenclature. So, excuse me. So you have a sequence of activities, so economic activities. In between themselves, they exchange flows, so it can be material flows or energy flows, and they end up producing a product or a service that is determining for the functional unit. So it's their function, their purpose is what this product system is doing. So this product system also has boundaries uh, that separate the product system with the encompassing environment, and they exchange with this environment a set of flows, which are input flows, and then they also emit a set of flows from the product system to the environment. The life cycle assessment intends basically to assess the potential impacts, environmental impacts of a given product system. And the way it's done, it's with a set of sequential operations or activities. So the first one is basically goal and scope definition. So you have to set the goal, the objective, and the scope of your product system that you want to analyze. After that second stage, that first stage, you will set to the stage which is the inventory analysis, and it's one of the most significant and most heavy load in terms of work to develop is the inventory. So you have to build up and collect the data that will then be used to calculate the environmental impacts for this second stage of inventory analysis. And then with that data, you can then calculate the impact assessment using environmental impact factors that convert the inventory data into the impact assessment. All along these processes, you have the possibility to do iterative iterations. So you can go back and forth to improve and to adjust on the goal and scope definition, or to complete the inventory analysis with additional information that it may be required, or even when doing impact assessment, you can choose between different methods that you can use to to calculate the environmental impacts according with the goal and scope. And of course, you have then the interpretation of those results, which will be adjusted to what you are looking for when doing the LCA. One very important concept is the concept of the functional unit. So every product system or every service system that is being assessed with LCA has to be assessed for a specific functional unit, so that it is possible to compare the environmental impacts of a specific and given function. So these are the main stages. I just got with them, but they are more or less described here. Then one very important thing as well is the principles of doing LCA. So LCA is basically a methodology, and the results are highly dependent on the way that we use this methodology in a way that we develop it. So there is a set of principles that the scientific community has developed and set for the development of this type of methodology. And I have the main ones here. And basically, so it begins with life cycle perspective. So it's important that the assessment that is done is doing with an overview and a perspective that incorporates the whole life cycle perspective. It's of course not necessary that we address all life cycle stages, but we have to consider them all. Um, Also, it should be with an environmental focus, of course, to address the environmental impacts, which is the main focus of this methodology. It has to be relative to a functional unit. So as I said, this is a key concept that we can only measure or calculate the environmental impacts of a given product system if we very well define what is that product system or that service providing as a functional unit. So it's all relative. The methodology is relative, and it has to be relative to a very specific functional unit. So it's one very important step of the LCA development is to define the functional unit, and we'll talk about it just in a few moments. Then it has also the principle of iterative approach. So it's something that you can always go back and change or adjust or improve the previous stages, as I said, to set a bit better the goal or the scope of the assessment. We can change that. We can also change and improve the inventory, so we can collect more data or data that is for a given process that may be important for the assessment. And so it has this nature of iterative approach. It also has to be transparent. So it's usually a highly complex methodology with a lot of data, a lot of information, and it's important that it is transparent so that the results don't just fall off out of the sky, and that anyone can just go back and check where the results are coming from. It has also to be done in a way that is comprehensive. So to consider the different attributes and aspects of the natural environment, the human health, the resources. So to not to look at the environmental performance just from one side or from one perspective, and needs to have a comprehensive overview. And also one very important principle that it's highlighted here is, of course, the scientific approach. So the decisions that are taken when doing LCA should, of course, preferably be based on natural science. Sometimes that may not be possible, so other scientific approaches have to be used, potentially using social and economic sciences, but of course we try to avoid these as to avoid to enter social sciences. Um, but anyway, it's 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 a plus sometimes because it allows you to have the assessment from perspectives that otherwise, if looking only at natural sciences, you could not reach. Um, Also, it doesn't, well, uh, if it's not possible to have a scientific approach, then it's always possible to introduce something that is non-scientific. But in that case, of course, there has to be a real judgment on that on the use of such judgments, and that is also be it's important to have like transparency, and whenever possible to have like a third party or an independent party that is also accompanying the development of the LCA methodology that can be used as a critique of the decisions that are made. So just to we are coming near the, the the final of this first part that I'm presenting, but it's important to understand when LCA can be useful and when it cannot be useful or it should not be used. So it's very useful for an internal assessment, so to compare environmental impacts of different products that have, of course, the same function. Also to compare a product's environmental impact with a given benchmark, to compare this, for instance, with the best performing product in the industry, and you want to see how your product can compare to that. Um, it's also a very good methodology to determine which environmental stages are more dominant in terms of the environmental performance, so that you can also try to improve on those stages rather than just trying to improve every part of the product. Also, it's important for eco design to identify those opportunities where we can do changes in the products and have a significant gain to its environmental performance. And of course, to help the company do an internal strategy that can change its, for instance, product portfolio or its service portfolio in a way that it becomes more sustainable. Also looking at external uses of LCA. So companies or the developers of LCA can use this for marketing purposes, so to basically communicate those results for information and education of the client or of public in general, also for lobbying purposes and also for labeling. So it's there is a set of, for instance, product environmental declarations that can be developed using LCA, and then they can be used as labeling purposes. So to communicate information on the environmental performance of a given product to a customer or to a business-to-business customer. So this is one of many uses that LCA can have. But also LCA should not be used for some uses. In particular, to compare products that have distinct functionality. So when we are talking about products that are completely different and they serve for different purposes, we should not compare the environmental performance of those two distinct products. Um, Also, it's not a good replacement when we have results that depend on the location. So um, it may be used as a complement methodology, but it's usually not very interesting or very accurate to be done. So basically, we cannot translate a given LCA result from one country to the other because the conditions may be totally different for the processes, and the life cycle of the same product may be different. And so LCA has to be done specifically for each country. Um, Also, it's not, of course, a substitute for any risk analysis or strategic assessment. So it's a very specific uh, methodology that cannot replace these more strategic tools. So I leave some LCA resources, some links that you can then later on uh, check with some databases and some information about LCA, how to do this, and also about software that can be used also to do this type of methodology. And so this basically concludes the first half of this first part, where we addressed basically the fundamentals of LCA, so the principles and what the methodology serves for. And now we will be looking at the sequence of stages that we use to do the LCA in practice, so to develop the methodology and do the studies. So just a quick reminder or a quick overview of a more detailed set of sequence of activities. So as you can see, it's quite complex and very significant number of activities that we have to do to develop a study. They can be grouped into those three or four main stages of goal and scope definition to begin with. And then once you do that, you have to develop the life cycle inventory. So to do basically the collection of the data, to relate that data with the unit processes, also to connect that data with the functional unit. So it's, an intensive process, and it's usually here to develop the inventory, the most hardworking or the biggest load in terms of doing the LCA studies is at this part. And then at the end, once you have concluded the life cycle inventory, you can do basically the environmental impact assessment. So where we can do the conversion of the information that is from the inventory into impact assessment to the impact categories. And then, of course, in the end, we do the interpretation of those results and do the conclusions in the report. So this set of complex and very big number of tasks can be presented into big four groups of activities. So first, the goal and scope definition. And for the goal and scope, I would just help you to understand that um, the scientific community identifies basically four types of goals. So we can have goals that are intended to support any decisions to change basically the product system or the service system. And in that case, you have goals that are more for the small scale when you are looking at micro level decision support, so very small and very specific change that you are looking to improve your product or your service, or when you are looking to improve a larger scale, so a bigger number of life cycle stages. So when you are looking at the whole product system, in that case, you develop a goal which is on the situation B type. So it's for large scale decision support. And then you have those goals that are for uh, not intended to have any decision support. They are simply for accounting. So we will have LCA study that is to do to get a result and to do an accounting or a reporting of that result without influencing the product system. So it's basically more like a diagnosis, but without any consequence. And in that case, you will have the, the goals that will address systems for that have interactions with other systems and or systems that do not have interactions with any other system, and that is the difference here within situation C1 and C2. Regarding the scope, so scope, although it may seem relatively easy to define, mostly the borders of the product system or the service system, but it's a stage in the life cycle development that influences a lot of what will happen next. So it's important to have in consideration what is the product system that will be studied, the functions of that product system, or if you are trying to compare these with other systems, you have to take in consideration the different functions of the different systems. You have to set, of course, the functional unit, and this is very important. So it has to be very clear what is the functional unit for which we are doing the study. And of course, the system boundaries. So with foreground and background processes. So also to have in consideration what is the information that is within the foreground. So within the context of the processes that are immediately connected with the product system, or those that are running in the background. And although they are not related directly with the product system, they are working and they are influencing. So for instance, like when we are using energy for a product system, the foreground process will be the type of energy that we will be using. But of course, there is a background process that is producing that type of energy or that is generating and it is also distributing that energy. So despite not being directly connected to the product system, it will influence the result and the outcome of the environmental impact of that system. Also, we have to take in consideration allocation procedures. I will talk to this a bit more further down the road. Also, the selection of the methodology of impact assessment that we want to use, the data requirements, so what time period, what space, what type of technologies do we want to cover, which ones do we want to leave outside without coverage. Also, any assumptions that we have to do, any limitations that we identify. And then if we have a critical review, external review, it's always good, and the type of and format of report that we may need. So, but the most important I would like to highlight for you, basically to get acquainted with, is that it is important at the early stages to have a scope that is sufficiently well defined, but it's not critical if we don't fully define that scope and we can go back and revise that in a way that it is iterative. So it's always possible, as I said in the beginning, to iterate back to the other stages in the life cycle development, and we can improve as long as we advance in the development of the study, and we check for needs to change a little bit the scope or to address some processes that otherwise we had not thought about addressing. So this works iteratively. But the most important note is that we should always document every step so that we can go back and, well, don't lose our track of what we are doing and why we take those decisions while we are doing the study. So we discussed about goal and scope definition. The second stage and the most hard workload stage is the inventory analysis, or the development of the inventory, and then the analysis. So the inventory basically tries to collect the data and assess all of the inputs and outputs for the whole of life cycle process, that all of the processes that are included in the life cycle. So all of the materials, all of the energy that is exchanged, all of that has to be accounted with the inventory. So the aim is to produce a process tree or a flow chart, so a diagram of the different processes and their interactions. And then when we establish that process tree, we try to develop the data inventory. So we start to collect data from each event, so emissions from each process and the resources used uh, coming from the initial of the raw materials. Also, we try, whenever necessary, to establish the correct material and energy balances for the process stages. So it will be very common that we will have information for a given process, but that process is dedicated to our product, but it may also be dedicated in part to a different product. So it's good and very important that we have the correct material and energy balances to address specifically our product system. This is an example of the type of information that is required for a life cycle assessment character inventory of a given process. So we need to um, quantify how many resources and what type of resources are used for a given amount of one process. For instance, energy and the different types of materials and the amounts. Also, the from the side of the outputs, the emissions for instance, for the atmosphere and also for the water. So the different types of materials and the different amounts that are um, outputted back to the atmosphere and to the water relative to the amount of the unit process. Regarding the data collection, of course, we are looking to have the energy inputs and the raw material inputs and all of the material inputs. Also, any products or co-products or byproducts that may be connected to our product system. Also, the outputs to air and discharges to water and soil. Any other environmental aspects, as I referred. On the data calculation, it may be required that we have to calculate some data for the inventory. So not everything is measured or is available, and we may need to calculate. So it's very important that we validate the raw data, and also that the data that we collect or that we calculate, we have that related with a unit process. So it's different if I'm quantifying the data for 1 liter of milk or 10 liters of milk. So it's totally different. And I have to have the inventory data related with the given amount of milk that I am trying to characterize. And also it has to be related to the functional unit. So in that case, if the unit process is like 1 kilowatt hour of energy that I'm using, I have to have that for the process, and then I have to connect that as well with the amount of energy that I have to use, for instance, to produce 1 liter of milk. Also, any constraints should be, of course, stated in the report, and we have to take note of that along the development of the inventory. Then there is also in the data collection and the inventory development, there is also one of the most critical aspects in LCA, which may influence the result, which is allocation. I have here a set of slides for allocation, but I think I will not go through every one of those in detail because you can take a look at them later. But I just want to let you aware that allocation is a very important aspect because um, whenever possible, we should try to avoid the need to allocate. So to have a given process allocated uh, for our product and for another product that the process may be used for. But when we cannot avoid this, we should, of course, necessarily use that allocation so we don't double count or miscount the environmental impacts associated with a given product. So uh, we should always try to have this allocation related with physical and concrete parameters. But whenever this is not possible, we may have to be forced to use other types of allocation, like economic value or even social value. And that is the type of allocation that we have to take in consideration whenever needing to do allocation. So we have here just a very notice of a quick example, but when we, of course, produce a wooden plank, so a board, of course, the process or the machine will generate the wooden plank, but it will also generate the sawdust. And it's not possible that we separate the wooden plank from the sawdust. So if you are doing an allocation of the information regarding the process, we'll have to take in consideration the wooden plank that is the result, but of course the sawdust that is also a necessary result from the process. Also, when we have like a process that is doing two products, we should separate what is the information or the data that is required and associated with one given product and which one is related with the other product, so that we don't again we don't double count or that we don't miscount the information regarding one product in particular. So I'll have other examples here how we can basically go around these situations. We can extend the borders or the system borders, and when we have an information for the whole system and have not for a part of the system, and so we can do by difference. We can get the information regarding the allocation for what we are looking for. So there is a bunch of techniques to try and establish this type of allocation in the best and most rigorous way possible. But this is an important notice because the end results may may be very sensitive to this type of allocations, and so it's very important that we prevent any mis results or misunderstanding or misuse of the results because of a bad allocation or an incorrect allocation performed earlier. And this can also happen for recycling processes, so for end of life. And in this case, the allocation has not to do with impacts that are occurred, but with the impacts that are avoided. So in the case, if we are sending a given material from our product system to be recycled and the material is reused back again in our product system, the the benefit, the avoided impact from that recycling it's already solved because we are avoiding the use of given materials by using the recycled one. But if the recycled material is not used in our product system back again, but it's used in other product system, then we have a problem here for allocation. Who should get this benefit or this avoided this credit, this environmental credit should be our system that is generating the material that is then recycled in other product system, or should the other product system be the benefiter of this environmental credit? So this is just a quick example of how this can quickly escalate to become an issue that can generate different results and with that different conclusions. So I'll just skip this allocation and then move on to the impact assessment. So impact assessment is the end or the final stage before, of course, we do the interpretation, but to calculate the results. So impact assessment has, I will jump onto the next slide already. It's quicker to explain, and because we are a bit short on time, I prefer to do this. So we have like from the inventory, we have information about how much energy we are spending, how much materials and what type of materials we are using to produce a given product, how many kilometers we are using to distribute the given product, and what type of truck or fuel we are using, etc. The question now is how do we transform these into environmental impact? So first, we have to select the impact categories, so the indicators and the characterization model. So we have to transform that information, which is a physical information, into something that can be classified as a physical impact. So we assign this to LCA results. So we do the classification by identifying which environmental impact categories can those life cycle inventory data be related to. And then we can do the calculation. We have to do the calculation from the classification to the characterization. So in this case, we connect this information with the indicator of the environmental impact factor that establishes the relation between the physical occurrence and the impact occurrence. And so these stages are mandatory. So when doing life cycle impact assessment, these stages are, of course, necessary. Then there is additional stages, which is to transform those physical impacts into damage impacts. And in that case, which is the case of when doing normalization or when doing endpoint indicators, those those are optional. So we don't need to translate the environmental impacts into damage impacts. But I'll show you in the next slides a bit more easy to understand what I mean. So basically classification, we have to assign the impact categories. So for instance, if we have like methane or CO2, they can be assigned to, for instance, if we have emissions of methane or CO2, they can be assigned to an impact category that is called climate change. So we can just um, establish that that would be done as a classification. We would set up a climate change impact category, and we would assign the amounts of CH2, CH4, and CO2 emissions to that impact category. Um, but it also happens that those emissions can also be assigned to more than one impact category. So classification doesn't necessarily need to separate um, the physical emissions for different impact categories that are exclusive. So there can be overlaps between the physical data and the impact categories that we use to classify. Then we do characterization. And in characterization, we use the characterization factors. And this is what correlates the physical reality. So 1 kilogram of methane or 1 kilogram of CO2, how does that connect with the contributions to global warming? And in this case, for instance, we use CO2. CO2 is used as the reference unit for climate change. And we can compare the effects of methane with CO2 in terms of global warming, and that is 25 times higher. So we can establish the the correlation between each substance and the reference substance, which in this case is CO2, for to characterize basically the environmental impacts of the emissions and in terms of the climate change impact category. So this would mean basically that CH4 is 25 times higher environmental impact in terms of climate change than CO2. So here is just an example of a bunch of environmental impact indicators for characterization factors for the climate change and global warming potential for the different substances. They are all correlated with carbon dioxide, which is established as the reference unit. And then I would like to talk to you about indicators. So we have been discussing about the physical environmental impacts, how that correlates to indicators, to characterization factors. And then in terms of indicators, we have two sets of, or two types of indicators. So midpoint or endpoint. So midpoint, we can have a set of different categories which are related with a physical occurrence. So like CO2 emissions and CH4 emissions, and then we can correlate that with the CO2 data, which is the reference unit. And the same happens with other other impact categories like acidification or land use, where we can see the amount of land that is used in square meters or whatever, and we establish a reference unit, which is a physical unit. And those are midpoint indicators, and typically are methods that are addressed and focused to the problem, so to the occurrence, to the emissions that are being made. And then we try to have like um, endpoint indicators or endpoint methods, which are more trying to look at what is the damage that comes from those emissions of CO2, or what is the damage that comes from the use of that land or the use of minerals in terms of tons, whatever. And these methods are also trying to simplify the number of environmental impact categories, because usually the midpoint ones can only reduce these to up to 17 or 18 or maybe 20 impact categories. But that is a lot to try and understand the result from like 20 different impact categories. And when looking at the human perspective, the science tried to develop endpoint indicators which will try to translate in terms of human health, in terms of the changes to ecosystem quality, and also to the depletion of resources that can be not further used in the future. And so with a simple or with an example, again, with greenhouse gas emissions, for instance, like CO2, methane, as we have been talking, we can see that if we have like a midpoint approach, we will stick to the problem of greenhouse gas emissions and to how much global warming potential that generates in terms of reference to the CO2 emissions. But that doesn't really convey anything special for us humans trying to see what is the consequence of that. So the science has developed to try and establish endpoint indicators, which will try to correlate the emissions of greenhouse gases with the changes in the radiative forcing of the Earth, and the science then tries to correlate that with changes in atmospheric temperature, and then tries to correlate as well with changes in living conditions. So maybe the loss of habitats because of the increase in temperature, or because of the increase in seawater level. A lot of sea coastal areas are lost. They cannot be used for living purposes anymore. And so this tries to convey to units that are more that we can be in touch with them more easily, so we can have sensitivity to them. And in that case, we will have endpoint indicators, which are oriented for damage rather than just the original problem. I will just go very quickly through here. So the problem-oriented ones, there is a lot of different environmental impact indicators or categories like greenhouse gas effect, natural resource depletion, stratospheric. So as I said, it's more complex. It has a bigger number of environmental impact categories, and they are very hard to connect with each other and to connect also for our understanding in terms of consequences for our daily life. Damage-oriented methods, they are more connected uh, with our interpretation of daily life. So they have units to measure in terms of human health, ecosystem health, and damage to resources. Also, it's more simple, so it conveys from like 20 categories only to 3, so it makes it easier to interpret as well. And they are used very commonly to convey the messages, or to try and answer why should we worry about climate change or any of those environmental impact categories that measure physical gradients. Also, it allows to have like a single score, so an indicator which correlates the different human health, ecosystem health, and damage to resources in between them, so we can have like a total performance indicator rather than just indicators scattered along like 20 environmental impact categories. Of course, there is also a downside to this, is that the 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 more we get away from the physical dimension, the more we get into subjective dimension and or qualitative information based, and so the uncertainty it's also greater. Now, just before I move on to the next step, I just would like to talk to you about normalization. So, one of the ways that science has addressed um, the the presentation of the environmental impact results in a way that is more simple to interpret is to do normalization. So we have usually a lot of categories for environmental impacts, and they are hard to correlate with each other. And so one way that is very much used by the LCA community, I would say, is doing normalization. So what we are doing is we are dividing the environmental impact in each of the environmental impact categories. We divide that result by the normalized result uh, in that category. So one reference unit that is very much used is the average environmental impact in each category that a European citizen has or generates during 1 year in the region of Europe. So that is easy to calculate as well, because you can add the total population of Europe, you can add the whole impacts of of the population, so it's easier to get data, right, rather than just have like very specific data for a small population or just a set of individuals. And this is very much used to compare the given result with the normalized average result of a European citizen throughout 1 year in his normal life. So this allows the process of normalization allows us to see which of the impact categories are negligible, so which ones we can basically left out of our analysis, and also the order of magnitude between the different categories, which sometimes are not correlated, but in this way they are correlated because they are compared with the same reference of the European, the average European citizen impact throughout 1 year. And this chart is just one example. So we can see here, for instance, in the x-axis, we can have the environmental impact categories, and then we have the amount. This is for beverage containers for 1,000 liters, and this is different materials that were tested or analyzed to perform like 1,000 liters beverage containers. So what we can see is, for instance, ozone and carcinogens and pesticides are negligible categories. This doesn't mean that they have zero impact, they don't. But when compared to the average impact of the European citizen for 1 year, they are practically negligible. So I think we can, in terms of assessment of the results, we can basically forget about these categories. The other categories, of course, we can see which ones are bigger compared to the others. Of course, the units are different, but in this case, they are normalized. So we can have at least an idea that compared to the average impact of the European citizen, you would basically conclude that the most significant environmental impact categories, the energy, maybe the smog, the summer smog, and maybe the acidification and the heavy metals. So this normalization process will allow us to basically focus on the most important impact categories that we should address in order to assess the environmental performance of the product and also to try and improve that product. Then just to finalize, of course, we have damage assessment. I've discussed about this endpoint issue, so I would not take any more time in here. And also one aspect that I would also like to well, not to talk very much, but just to let you aware of, in the same fashion that I discussed the allocation issue in the inventory. So we have to allocate the data for different processes to ensure in a correct way, to ensure that we are not double counting or miscounting. Also, there is a controversial aspect in LCA, which is weighting. So it's the basic to try and correlate the different environmental impact categories. As I said, we cannot compare like square meters of land used with kilograms of CO2 emitted to the atmosphere. So it's totally different units and different physical realities. But somehow, if we are assessing the environmental performance of a given product system, we have to be able to connect those two impact categories. And so what weighting does is exactly that. It tries to correlate the different impact categories. This is done using basically social sciences. So people are asked what do they value most? Do they value most the increase in air temperature or the loss of habitats or whatever? And so this is the way that weighting is done. And so many of the midpoint methods have then weighting procedures, and that can be used. They are, of course, have a lot of uncertainty and they are controversial, but it's a necessary step sometimes to get an overall result for the environmental performance. But I would just let you aware of this controversy that is doing weighting, but it's sometimes a necessary step. So this is a very summarized overview of the RECIP method. So this is one of many environmental impact methods, but it's one that is very commonly used in LCA studies, especially in Europe. And this, as you can see from left to right, you have, so first in left, you have the life cycle inventory. So you have the amounts and the types of resources that are used and the emissions that are done. And then that it is connected with environmental mechanism part one, which is the different environmental impact categories that are defined in classification. And so, for instance, CO2 can be connected with the global warming potential, or ozone can be, or CFCs can be connected to ozone depletion category. So this is a definition or a classification which is relatively solid in terms of physical units. Then that can be translated into effects. So this can affect the occupied area or the emissions of particles or the ozone concentration that is changed. And that can also then be transformed into environmental mechanism too. So it's a step closer to endpoint. So when we have midpoint, as I said, it's very clear that we have very defined physical units, and we can measure that. When we are coming into endpoint, it's usually more difficult to correlate or to measure how much of the, for instance, the decrease in ozone concentration, how much does that affect the living habitats in, or the number of species that exist in a given habitat. But the science has developed very much, and there is a lot of studies done, and they allow to have factors that correlate one with the other. And so today it's possible to have endpoint indicators in terms of especially human health. So it's a unit which is DALI, which is disability adjusted life years. So it's basically a measure of the change in our life expectancy with quality of life. And then we have ecosystems quality, which is calculated in terms of the species per year that are lost. And then we have also resources surplus cost, which is basically a unit of how much additional cost do I have to bear to get the same amount of resources that I would use to get in the past because of the use of resources. So this is a very summarized overview of the midpoint and endpoint methods. And so finally, just to conclude this part of the LCA stages, we have the LCA step 4, which is the interpretation of results. This should be, of course, done throughout the entire development of the LCA study. It also may affect, of course, the goal and scope definition and the inventory, but it's mostly done, of course, in the end when we already have the calculation of the environmental impacts. So we try to, when doing interpretation, we try to identify which are the significant issues for the environmental impact performance. We do this based on the inventory data, also on the results of the impact categories, and the contributions from the LCA stages and process to the results. So we try to see if, for instance, the production is contributing more to the environmental impact, or if it's the use stage, or if it's the end of life stage. So that is one important aspect of doing the interpretation. Also, we have to do the evaluation of the completeness, sensitivity, and consistency checks. So this is more like a formal step when doing interpretation of results. So to be sure that we have done the allocation right, that we have considered all the information and data that we needed to consider, and that the data is consistent. So it's more like almost an internal task that we have to do when interpreting. So it's not very much interesting for the users, but it's more like from the practitioner side. And then, of course, we have to draw the conclusions and identify, of course, the limitations and try and establish the recommendations.